All right. Hey everyone. This will be our. Sorry for restarting, but this is our FTC Java for FTC beginners workshop. My name is Salam Mehta. I am um, a member of FTC team 14162 Bots and Bytes, and I'll be discussing Java for FTC beginners. So how do FTC robots work? Well, there are two phones that you'll be using. One is the driver station phone and one is the robot controller phone. And both of these connect through a Wi-Fi direct connection, which you'll be able to manually set through the phones and through Wi-Fi direct connections from your phones to your laptops. And you connect your controllers to your driver station and you connect your robot controller to your robot. And through that, you'll be able to manipulate your robot's motion through the controllers. So there are a few ways of programming your FTC robots. One way being the block programming, as you can see on the screen over here, on the picture over here, where you'll be using blocks in order to program your robot to do various things. There's OnBot Java, which
recording in.
Excuse me, can everyone mute? Elizabeth, questions will be at the end. If you have any other things, then.
Actually, it's really important to what you just said about the phones because they switched the controller hub. So you don't use Android phone anymore?
Oh, I believe you can use both the new and old versions. So there's the control hub and then the Rev expansion hub. So you can connect your phones to your Rev expansion hubs, or you can use a control hub, which which doesn't require a phone, but you'll have to directly program to your control hub.
And you do that through a computer?
Yes.
Okay, thank you.
So there are two ways. Yeah, this is more of using the old, but however, if you do get the control hub versions, which I believe they'll be giving in their new sets, you can directly program through your laptop to the control hub. So that's one way of doing things. Yeah, I should have also mentioned that. Sorry. So yeah, these two ways, on block programming and OnBot Java, you can connect through Wi-Fi, which is also available with the control hub, and you can program to the control hub through those, or you could use an IDE like Android Studio in order to program directly from computer and to your robot controller through wired connection rather than a Wi-Fi connection. So both OnBot Java and IDEs require you to use Java syntax to program your robots. However, OnBot Java allows for a Wi-Fi direct connection with the robot controller, which allows you to test your programs much more faster because you don't need to unplug your robot controller from your robot. And when I mean robot controller, I mean robot controller phone. Whereas with IDEs, they allow you to program your robot with various libraries and various different techniques compared to OnBot Java. However, you'll need to plug in your phone to your computer in order to update the code and then put your robot controller phone back onto the robot to test the code. So I'm making sure this thing is recording. Yeah. So how do I get started with OnBot Java or block programming? Well, you'll need to download this specific apps for your phones, one being the robot controller app and one being the driver station app on both phones. And then you can connect your phone through Wi-Fi direct, which you'll be able to manually set through the phone. Then you open the FTC robot controller console on your laptop, and here are some resources in order to how to specifically do this, but this is like the basic simple steps on how you would program through Wi-Fi direct and OnBot Java in block programming. And this presentation will be shared with everyone at the end, so you won't need to worry about the links. So Java IDE. So and IDEs are short for Integrated Development Environment, and it's basically an application that allows the user to write and debug code. It's basically a text editor with a compiler and an executor, and generally for FTC you'll be using Android Studio, or you'll be using the built-in IDE from OnBot Java to program your robot. So here's a good example of what Android Studio look like. So now we'll talk a bit about the actual code. So
Hey, Sahil. Yeah,
hello?
should I do this next few slides on the basic of Java?
Sorry. So basic syntax of Java code. So this is the basic syntax you'll be mostly working. You'll have a class and a few functions. So public. I'll get into the more details on what syntax, how the syntax works. But as you can see, you'll be using one of the main focuses with Java. Things you'll need to remind yourself is working with semicolons, which is if you have ever worked with Python, will be a bit different. And as you can see, there's a few you can create functions through public, static, and then either void or a specific variable, which we'll go into more discussion about. But here's a kind of a basic syntax of or basic look of what Java is like when you're programming. So a few things that you will want to learn about know about before working with Java. It would be classes and methods. So a class essentially is an object where you can set some certain variables and methods, and they'll exist in the class. And all of these methods and variables can be accessed in the class by simply calling the class, which as you can see, one example of a class would be class car, which has variables color, size, and max speed. Methods. A method is basically a function, and you can put in a value, or you don't need to. And then from there, you can return a value, or you do not need to. So you can have various types of functions. Some of them you can add something into it, and it'll return something. And some of them you don't need to add anything at all, and it'll print something out. So example of a method would be move, stop, and auto drive for car class. And note, each program you'll write in Java is essentially a class. It has functions in the class that are being run. And you can also have multiple classes in a program, but there will be one main function or one main class that'll be run in the program. So another thing you'll need to know about is variables. So all variables, a variable is essentially a way to store data store any sort of data like integers or strings or lines of code, just normal lines of text. So all variables in Java must first be initialized to be used. You can't simply just say x equal to 1. You have to say the data type and then the name of the thing, and then you can equal it to something. So this is an example of how you would initialize, and then you can state Bob is equal to 1. And if you run this code, nothing's happening because we haven't actually put any value into Bob, so it won't do anything. But if you enter, say int Bob is equal to 1, then you'll set the Bob value to 1. So primitive data, these are some of the data types the basic data types you'll be working with. So there's byte, short, int, long, float, double, boolean, and char. So each of these are stored their own type of data. So in the two main ones you'll be working with mostly will be int, double, and boolean and char. So int stores numbers, whole numbers, and same as short and long, and bytes. Float and double can store decimal numbers. So float is big enough to store 6 to 7 decimal digits, and doubles are able to store from up to 15 decimal digits from both positive and negative side. Boolean store true or false values. So you can say Boolean of Boolean Bob is equal to true or Boolean Bob is equal to false. And char stores a single character or letter. So operators are used to define and manipulate variables. So these are the few operators you'll have. There's plus, minus, multiply, divide, modulus, increment, and decrement. So as you know, we all know the basics: addition, subtraction, multiplication, division. However, modulus divides your value and gives you the remainder of the value. So if you say 10 modulo 2, you'll have a remainder of 0. If you say 9 modulo 2, then you'll get a remainder of 1. And because we're getting a remainder of 1 from 9 divided by 2. Increment and decrement just increase the value of a variable by 1. And you do not need it. So, and this allows you to just say x plus plus rather than x plus 1, x equal to x plus 1. So what are loops? Loops allow for the repetition of a certain action without any minor changes made to the action. So some examples would be a if-else loop, for loops, while loops, and the concept of recursion. Example of a for loop, as you can see the first image. Let me see if I can bring out. As you can see here, for int I equals 1, I is less than equal to 10, I plus plus. So what this is saying, for we have set a variable int I is equal to 1, and then we have said that for when, well, while I is less than equal to 10, then we'll increase by I plus by 1. And so now here we'll be printing out I, the value of I, and it'll continue looping until I is less than or equal to 10. So by that meaning, once I is equal to 10, then I'll stop running the program. While another example of a loop would be the while loop, as you can see here. So while I is less than equal to 6, we'll be printing out the value of 6 and then increasing the value of 6 after we print it out. So these are two ways of writing a loop, and they're each used for their own cases. So you'll be seeing many examples of how to use them in basic in FTC programming. These are like some of the foundation loops that you'll be working with. You'll also be working with recursion and if else. So those are some like really important things to know. So the difference between basic and FTC programming, there is no main method, exactly a main method in FTC programming. I'll show you an example of what FTC programming looks like, but just know that there is no main method in FTC programming. This is if you have experience working with Java before. If you have not, you'll probably stick with the block programming, which is a few people have to join. Which is very similar to, which will help you get ready for working with Java programming. So there are two types of programs that will be written for your FTC competition. There's, as you saw, if you saw the trailer already for this year's competition, you'll know that there's an autonomous period and a teleups period. And so, or driver control period and an autonomous period. So the autonomous period, you'll write an autonomous program for the robot. And for the driver control period, you'll write a teleops program for it. And you'll be working with multiple different methods and variables from the FTC library that allow you to control different parts of your robot, lets you use the controller to control your robot, and can make your robot do much, much more in autonomous. And one important thing is that there's a lot of math involved, especially if you want to better your robot programming, there will be a lot of math involved. So just be aware of this. So I'll give you some examples of FTC code. So this is the GitHub repository from the FTC robot controller, as these are some samples. So one being the iterative format. So if I don't think you guys will be able to see right now, let me share my screen. Oh, share screen. So as you can see here, this is an example from what they from FTC robot controller GitHub repository. So this is kind of how you'll be writing your programs. This is one way being the iterative op mode. And you'll need to import some certain libraries in order to start programming, start using these various functions that you'll be seeing here, like private DC motor left drive equals null. So we'll be sending you the links to these as well in after the presentation's over. But one of the things, so how to explain? Yeah, so start off your programs with the iterative op mode. You'll be writing public void init, which will initialize your robots and will initialize all the various accessories in your robot, or electronics in your robot. Then you'll press start, and then you'll start the loop from there, which will loop until the end of your teleops period. This is mostly used for teleops, and you can definitely use this for autonomous, but you'll have to set the op mode to autonomous instead of teleops, as you can see here. This, when you say import.com.qualcomm.robot.core.event-loop.op mode.teleop, you'll be specifying that this is for teleops only. So you'll need to change this to autonomous whenever you want to work with in terms of autonomous programming. And you'll also need to change your group or your ads over here to autonomous versus teleops in order to set it to if you ever wanted to run a teleops code or autonomous code. And as you can see here, you have a few variables you'll be working with that will control the motors of your robot in order to move it around. So if we were to run this code, this would allow me to move a basic robot forward, backward, left, and it will allow it to spin as well. And you can, as one of the things that you would want to note is telemetry allows you to display certain information that you specify in the function to your driver station screen, and as well as the robot controller screen. So this is the iterative op mode. Linear op mode is a bit different. This one starts off with the public void run OP mode. So this one, you press the program, and then this allows you to initialize all the various parts on your robot. Then you wait for the button pressed again in order to start the running of the running your program. And it's this part is basically the same as the iterative op mode example that FTC has provided. But the format of how you program your code will be a bit different based on the type of way you want to write your code. So versus linear op mode versus iterative op mode. So how will your team manage your code? Well, one of the biggest suggestions would be using GitHub. It's one of the greatest tools for programmers. It allows you to keep your code online so that everyone in your team can access it. You can collaborate with your team by sharing newly edited code. It's a great place to have discussions on code, and you get to view other people's code to get more ideas. Any questions? Anyone have any questions? Just raise your hand if you have any questions. Or you can unmute. Can you guys hear me?
Yes, we can.
Okay, yeah. If you have any questions, just raise your hand and I'll, Aryan, yeah. Question?
So basically, for like the classes, like, do we have like these inbuilt classes that like follow the line or like use gyro sensor to follow the line, or do we have to like program that ourselves?
Could you repeat the question? I wasn't, there was a bit of static on your side.
You have to program it yourself.
Okay.
Anyone else, any questions?
Which would you recommend, linear or iterative?
Personally, for me, linear op mode is much easier to work with just because you could easily see the code. It just, for me, it makes the most sense. You know, you press the button, it's initializes some certain your electronics, then you press it again when you say wait for start, and then it'll start running their code. It just looks visually appealing to me, but it depends from person to person. Some people in my team prefer working with the iterative op mode, and some people like working with the linear. It depends on the person and how they generally program, but personally for me, I prefer the linear op mode.
I'd actually recommend the opposite, that you go with an iterative mode, because it allows you to do several things at once. If you try doing the linear op mode, you're often stuck in this situation where you want to go to sleep. And going to sleep in robot programming is sort of a bad way to make a delay. It's better to run a state space algorithm where you watch the clock and you check the clock occasionally to make sure when the time is up.
I'll definitely note that. Yeah, definitely. That's a good point. Arya, if you have a question. Oh, Manoj.
So I don't quite understand the difference between linear and iterative. Is it about threads or something else?
No.
It's about, sorry, yeah.
No, it's not about threads. The linear op mode is like most people learn how to program, that you just start doing one thing right after another. And that's sort of okay as long as your robot is just doing one thing. The iterative op mode is more like a night watchman, that you may be running, you may be trying to achieve several different tasks, but what you have to do is every 25 milliseconds or so, check on those tasks. Like, has my arm moved to its ultimate position? If it has, then I can stop moving the arm and then go to the next thing, which might be operating the gripper. So linear is doing each step in sequence. Iterative is checking on things as they progress every 25 milliseconds and deciding whether you have to, whether you finish the operation you were working on or whether you have to wait. So you can be checking on 3 or 4 things at the same time.
So if I understand, sorry, quick question,
ahead.
because I didn't want to hold up the rest of the team. Does that include something like timer callbacks firing or some other mechanism?
I didn't understand the question. Repeat it.
Oh, so when you say you can check on multiple things on the background, is that involving timer callbacks or signals or something like that?
No, the timing, what happens is there's sort of an executive that FTC is running for the robot controller, and it calls one of 5 functions every 25 milliseconds. So there's at the start of the game, it's just not doing anything. When you press init, it calls the init function once, and then 25 milliseconds later, it will call a init loop, and then every 25 milliseconds after that, it will call a init loop. So there are these periodic, you can sort of imagine them as interrupts that are happening, that are calling those 5 functions in the iterative op mode. Now, sort of an example of what my team has done is it will run an odometry program trying to measure the position of the robot. And so during each of those 25 millisecond calls, it will look at the wheel encoders, how much they've changed, and calculate a position. And so it just does that all the time. But that's just one step in the iterative loop. I might be getting too involved here, but it's just.
That's okay, yeah. I feel like there's some people, or other people asked that wanted to ask question, but that was definitely a great answer, yeah. All right, does that answer your question, Kanoj?
Yes, thank you.
Okay. Elizabeth? Did you have a question?
I do. Sorry, my keyboard was being weird. So I wanted to know if there is a learning environment that you all recommend for students who are new to programming and particularly new to Java.
I would definitely suggest working with the OnBot Java. It's very simple and there's a lot of tips. However, you could also definitely use Android Studio. If you're very new to programming, I would definitely suggest starting with the OnBot Java and making your way into learning, the various parts of the robot from OnBot Java, as well as, learning a bit about various parts of the robot through the OnBot block programming. If you know a bit of Java, then it's great to start off with OnBot Java and then move on to working with the IDE, because that allows you to work with various libraries that you will be able to access once you move to the IDE. But for beginners, I would generally suggest OnBot Java or the OnBot block programming.
Dawn, can you say that again, please?
OnBot Java or OnBot block programming. You'll be able to access those through the phones, the OnBot or the robot controller app and the driver controller app. By connecting your Wi-Fi to the two phones, or to the robot controller phone. There will be some instructions on how to do that from the FTC website, but you'll generally just connect your phones to your computer and then program from there.
Yes, I've got a bunch of kids who are like completely new to programming and really interested in learning. So I'm just trying to figure out how to direct them.
I would definitely suggest working with the OnBot block program if they're new to programming. If they have some experience with Java, then I would definitely direct them to OnBot Java. But for beginners, it's definitely advised to work with OnBot block programming.
Okay. And then do you have to be connected to the phone or the bot in order to use that? Or is that something that they could do on their own time when they don't have
You'll
access
to
to
be
these?
connected to the, you'll have to be connected to the phone in order to do OnBot Java or OnBot block programming.
Is there something that they can access on their own time that doesn't require
You-
connection?
You could potentially, download the code from the phone and then work on your own time through a GitHub repository, which I believe there was a GitHub workshop, and they'll discuss how to
Yeah, I'm
manage
going to
code
that too.
online. You could
Okay.
you could definitely learn a bit more about how to manage your GitHub repository. So download your code and then manage it through your with each other. However, to actually execute your program, you'll need to connect your phone to the laptop in order to directly program to the phone, and then you can actually test your code. Otherwise, you'll have to, if you're in general, it's more widely known if you're working with OnBot Java, you're going to be with the phone and programming with the phone. Like if you have the phone on you, you'll have to program to the phone while connected, and then you can, update your code.
Okay, I'm sorry, one more question. If we're doing it that way, can more than one person be using the OnBot block programming with the device, or is it a one user only?
So one of the things that when we were working is that you can have multiple people connected. The issue is once you compile the code, it compiles the entire project. So what happens is let's say you compile the project or your project and two people are working and one person's not done. The compile will essentially save whatever whoever compiled it, they'll save whatever they were working on, but it will not save whatever the other person was working on. So technically you
Okay.
could connect, but it won't save what one of the people working on. So generally
Okay.
it'll be a one program at a time type of thing. Yeah.
Okay, thank you.
So this is one of the
I also-
biggest. Oh, yeah.
If I can come in,
Yes,
I
please.
also sense there's this notion of, could people work on it at home? And for the development environment that I use, which is Android Studio, to work on stuff at home, you need the robot, because if you're going to try executing robot code, you need the robot to actually execute that code. I don't know if there are alternatives to that.
Well, I guess I was wondering more about the learning aspect and just practicing how to write, an algorithm and function and that kind of stuff for people who really don't know any of it.
Yeah, so you can definitely connect. The issue is when you're to learn, to actually execute the code, you'll need the phone and the robot with you in order to but you can definitely work and then put once you get the access phone, you can put the code in and then execute and run. But yeah.
Okay. Thank you.
Arya?
So can you explain how to use like sensors and Java for like FTC again?
So there, you'll need to connect your sensors to the robot, either your expansion hub or Rev expansion hub or the Rev control hub, and from there, from what I learned using the FTC Java docs, you'll get a lot of details on the various types of sensors and like the gyro sensor, color sensor. From there, you could essentially use the various functions that they have in the FTC Java docs in order to program your sensors. I don't know the specifics because I right now haven't touched the sensors. However, there's a lot of information from the FTC Java docs. I'll be putting the link as well when I send the presentation to you guys. But yes, using the FTC Java docs, you can get a lot of information from how to program your robots and the sensors, as well as the sensors and other electronic components.
If you look in the GitHub source tree, you'll find external samples.
Yes, that one as well.
And
that's also a great example. Yeah.
And in external samples, they often have sort of single-minded, this is how you use the distance sensor, this is how you use the color sensor. So they're very simple programs, either in the linear op mode or in the iterative op mode, that show you how to connect the sensor, well, how to access the sensor, and some simple things you can do to it to find out what your gyro angle is and things like that.
Are there any like links so that like we can research on this? Because I'm not sure what an FTC Java docs is.
I'll put all the links after the presentation, but I can put them right now, if that is in the chat right now. So here is the this is something's weird. Here we go. Here is the link to the where is the chat? Okay, that's I don't think there is a chat feature. Apps. Surprisingly, I don't think there's a chat feature, so I'll very sorry, but I won't be able to chat. But however, I will be able to. Yeah, I'll be able to send it after the meeting.
Where
But
will you send it?
Huh?
Where will you send like the link?
I'll be sending email to everyone.
Okay.
I believe that's how it works. I don't, or I'll be sending it to the FTC, to believe if I'm able to send it, then I'll send it through FTC. Try to send it through FTC. That's what I remember. That's what we could do, but I'll have to double check with with Diane the Play at Learning on how to do this. But yeah, I'll do my best to try to send all the information through Playing at Learning.
Yeah, okay. And also, I'm not sure if you can answer this, but what are like the most useful sensors you would use in like FTC?
There's no one useful sensor. It depends on the situation. You know, there's the color sensor, the distance sensor, gyro sensor. It really depends on the situation. There is no like one useful. It just depends on the competition and how you want to use it.
Okay,
I guess the best sensor would be your phone camera, especially for TensorFlow, which will allow you to score a lot of points if you're able to complete the TensorFlow types of challenges.
So you're allowed to use your like phone camera during the match?
Yes. So the robot controller phone has a camera, and you can use an external camera, and through programming with TensorFlow, you'll be able to use those cameras in order to scan certain images or colors, and with that you'll be able to especially for this challenge, you'll be able to pick up your teams or your team specific item and place it wherever it was required to be placed, especially for this year's challenge. But that's one of the examples, and you get a bunch of examples on how to use TensorFlow from the FTC GitHub repository through external samples, as Jerry had said before. But yeah.
Okay, thanks.
Arnav?
So my question was, I have a little bit of experience with coding, but no experience with Java specifically. So where should I start?
I think best for me when I started programming, if you have, what type of programming experience do you have exactly?
JavaScript.
JavaScript. So JavaScript and Java aren't too different, but yes, there will be a bit of differences to work with. So I would suggest learning learning a bit about looking at the different examples that they have and learning a bit from external samples, and kind of relating the two from JavaScript and Java together. Try to get an understanding of how they work. You can take external courses on Java. That's what I kind of did, learning about the basics of Java, and then from there working with FTC Java. But yes, external samples is a great tool to learn the basics of FTC Java in general, and then FTC Java you can learn outside. You can learn through multiple videos. I learned personally, self-taught myself through a book, and from there I just learned how to program. But generally speaking, this it's great to explore the various resources you have online through external samples for basic FTC programming, and just other courses or books or whatever. That's the best way to learn Java and program in Java.
I think from a little bit higher altitude, there's an FTC introduction to Android Studio, I think.
Yes,
they
have a course. Yeah.
They did it a couple of years ago. I don't know if they've updated it or not, But one of the important things that you have to learn is how to configure your robot. And that's sort of the only document that I've seen that has sort of everything in it. So that if you want to have a motor, you have to get into configure, you have to set up a configuration that says, I have a core hex motor plugged into port 1. And it has the following name of, motor 1. And then in your programming, you end up, this applies to the Java programming. You then have to do a hardware get of that kind of motor with that particular identifier that you gave it. Because you have to go through all of those steps before you can actually get things on the robot to move.
But in terms of learning just basic programming, yeah, it's just, you'll be able to explore from the various examples, and you'll also learn from the external samples or the internal samples from the robot controller itself. So, and to actually execute your code, to like test if whatever you learned is correct, you'll have to configure the robot through the FTC robot controller, and then from there you'll be able to test your code out. But yeah, does that answer your question, Arnav?
Yeah, it does.
Anyone else? Any questions? Arya?
What is the difference between a DC motor and a servo motor?
A DC motor. Oh,
And in like coding terms, like to use them.
so I believe by servo motor you're talking about either the CR servo or a generic servo. So the difference between a DC motor is they're just like the DC motors are just generally like a motor that you'll be using for various high power tasks or high torque tasks. Versus a servo, they'll generally have either a CR servo or a normal servo. Servos generally have a set limit for how much rotation it can have. So it can either have 180 degrees of rotation versus 360, and versus CR servo, which has 360, and it can move continuously. So with a CR servo, you can set the power like a DC motor, except for the fact that it's a bit slower. It's not really used for high torque situations. And normal servos, you'll be able to set the position based on the degrees that you want it to turn. So those are the two biggest difference. It's just in terms of program. In terms of programming, it's the way you set up the connections on the robot controller and the objects that you create from the classes DC motor and servo or CR servo. And that's kind of, and then yeah, this, as I said, you can set positions for servos. CR servo, you can set power and it'll spin continuously. The same as motors. Motors are a bit, you'll be able to visually see the based on the amount of power you set to it, how fast or slow the motors are. Personally for me, when I did that with the CR servos, I couldn't really see too much unless of course you set it to a very low speed. But yeah, that's kind of the basics of the difference between CR servos servos and motors.
So what would you use like a DC motor for, and what would you use a servo motor for?
So a DC motor, I would use it for making the base of the robot, so making the robot be able to drive. A CR servo or a servo, I'll generally use that for maybe picking up some certain objects with a claw. If I want to create a claw, I use a servo in order to create that motion, and without using high powered objects like a motor, right? Because you only have 8 slots for your motors, so you have to choose wisely, right? So you'd use it. Generally speaking, you use your motors for things that require a high power or high torque, and then you'll use your servos for generic motions. So, yeah.
Okay, and I was also wondering, I saw some robots like they're going in all directions, like back, forwards, right, left. How does like the robot do that, and how would you like code it to do that?
So those robots have special wheels called mechanism wheels, and you can get them from the AndyMark or various other websites or FTC legal websites. And they program it in using, I believe, either trig or basic, a bunch of math in order to make the robot, the set the specific speeds of each motor in the base in order to create it to make it go, forward, left, right. And there's the wheels that they use are called mecanum wheels. If you need me to type it or just don't chat, it's spelled MECANUM, mecanum wheels. And that's generally what the teams will use in order to, make their robot move left, right, up and down, diagonally. And it'll use math, a bit of math, or you could use just pure algorithms in order to create that, left and right motion. I suggest doing a bit of research or, looking at different teams and seeing what they've done and, learning from them.
Okay.
Any other questions? Yeah.
Hey, so you were saying you're going to be sending out pointers to the GitHub code. Is that right?
I was going to be sending this presentation as well as a few links that that we discussed, like the FTC the FTC GitHub repository and the FTC Java docs. I believe that's, I don't know how the playing and learning people will set it up, but I'll be sending it to them and then they'll be able to, I believe they'll send it to you guys.
I see. I had a quick suggestion. If you already know the GitHub repository or the FTC website, you can present it and folks can jot down the website address. That way,
Sure,
we're not
definitely.
completely dependent on that email.
Definitely, yeah. Let me do that then. Let's do that.
The last time I checked, I didn't see a specific repository for this year's game yet.
Yeah, they have not said it yet, and I looked like extensively, and they haven't put it into their GitHub account. So as of right now, I'm just working with the latest, whatever they have, the latest one. Let me pull them both up just for so that you guys can work on check them out. This one is the 2021. Let me see. I'm just gonna double check again. Maybe they did put it already, and I can just show the latest one. But if not, okay. So presumably, because they updated it 18 hours ago, I'm gonna assume that the one that they'll be using is this one right here. Let me share my screen. Yeah. So they just updated this 18. Let me just pull this out of here. Yeah. So this is the one they updated this, I believe, 18 hours ago, and this is your FTC Java. This is the link, github.com/firsttechchallenge/FTC robot controller. This will be using for, I believe you'll be working with this repository to work on your code. I believe FTC GitHub repository, the GitHub workshop will be discussing more about this, but I believe based on what the latest updates, this is what you'll be using. Code can generally be translated from so if you were working with the older repository, I'd suggest moving to this one. If they make a new repository, you can copy your code into that the newer one. But from what I'm seeing, based on the activity, this seems like the latest one that we'll be using for this year. Maybe they'll update, the README, as you can see here, what how this will this information. But from what I know, this seems what we'll be using this year. Yeah.
Can you repeat the GitHub link?
Oh, yeah. Hold on a second. This one. This is called github.com/first-tech-challenge/FTC robot controller. It's on the top right. Let me see if we can. No, that doesn't work. I wish I could just put in the chat.
Oh, can you just repeat like this? Like it's first-tech-challenge.
This is right here. If you can see, right? Can you see my cursor?
Can you move it?
Oh.
I don't see your cursor.
Wait. Okay.
It's really small text.
Oh, really? Does this work a bit better for you guys? Yeah, this is what you will type in. So github.com/ and then whatever you see right here. this first tech challenge / get FTC robot controller. Or
Yeah,
let me
it's
try one.
extremely small.
Let me try one more thing and then see if that works a bit better for you guys. Sorry, I'm gonna give me a few seconds. Okay,
I think that has
so-
old Gradle files in it anyway.
All right, here, let me share the second, and then Java docs.
Okay, wait, I think I got it.
Just for anyone who couldn't-
Capitalization.
yeah, just for anyone who couldn't see it, let me just present this and then share my screen again. All right. These are the links. If you couldn't see before, here they are now. So github.com/first tech challenge /FTC robot controller, and this one's first tech FTC tech nh.github.io/FTC app /doc./java doc /index.html. I do not know if they have a newer version for their newer for the FTC robot controller, but from what I've seen, this is what I generally work with. You'll have to, I believe I haven't I checked around. They don't really I didn't see anyone for anything for the new Java doc for the new robot controller repository. So I would suggest working with this for now until they announce one. Or if you have any, if you guys know about if there's any other way, that'd be great. Or any other Java docs, that'd be great. But this is what you'll generally be using for in terms of getting any information about different parts of the robot. Yeah. Kanoj?
Okay, awesome. That was pretty good because we got the links. I had a quick question, maybe to you, maybe to other people on the call that may have used this. Has anyone worked with Pure Pursuit, and what is your experience?
Oh, God.
Has anyone worked with what?
Pure Pursuit?
Okay.
Yeah. So I have had a bit of experience with Pure Pursuit, but I have not worked with it. It's a bit math heavy. I believe gluten-free 1115 gluten-free, or that's their team name. I believe 1 year use Pure Pursuit. You can definitely check their stuff out. That's from what I remember. I believe it was from the Rover Ruckus year. I think that was I believe 2 years ago. Yeah, 2 years ago they competed at the world level and they used Pure Pursuit from what I've heard. So you definitely can check them out. In terms of we have not used Pure Pursuit, however, our team has not used Pure Pursuit, no. So if anyone else has experience, that'd be great if they want to pitch in, but from our team, we have not used Pure Pursuit. Just for anyone who wants to know, Pure Pursuit is essentially working, finding the tangent of a circle and using that as a pathway. Personally, that's a bit math heavy for us, so we did not work with that. But if anyone else, is interested, you should definitely check out there's a bunch of information online that you can definitely check out. Aryav?
I had one last question. Like, on like the FTC field, if you're on two alliances, the red and blue side, you know how like your carousel for like the duck is on either the left or right during our autonomous period? How would you know whether to go left or right, like depending on which alliance you're on during the autonomous period?
If this is a wait, is this like a wait? Can you repeat the question? Because I think you're talking about like a very specific to this year's challenge.
Yeah.
I think the simple answer is you might, for example, have 4 different autonomous routines. 2 of them for blue, one starting on the left, one starting on the right, and 2 of them for red, one starting on the left, one starting on the right.
Okay.
So that you would know, because from your talking with your alliance partners where you're going to set up. And typically a team could have several autonomous programs, depending on where they start and what they intend to do. Because sometimes your teammate, your alliance mate may be very strong and tells you, okay, just sit there for 20 seconds, and then in the last 10 seconds, go park. Where others are, gee, I want you to handle one task while I handle the other task.
Yeah.
So in your planning, you should think about how you're going to interact with your alliance mates and develop your autonomous program or your autonomous programs accordingly.
And also another point, since I understand your question, so when working for programming or autonomous code, one of the things you could definitely do is make a program and then at the competition, display how your robot's gonna like move. That allows your other alliance partners to see, okay, if this guy is doing this, then how about we change our code just a bit so that we can try to follow, try to match what he's doing and make sure we don't bump into his robot. So yeah, generally speaking, when you're for a competition, you'll generally have 2 positions for the red and 2 positions for the blue, and so you'll make a program for each of them in order to do whatever task you want at each of the various positions. And one of the things a lot of teams generally do will present what their pathways are to the various alliance, their very other teams, to show that, hey, this is what we're able to do. Now, if you're gonna work, if you're competing with us as part of our alliance, then here's what we do. Is there anything else you want to change for your, or should we change so that we can match up with your type of your program? So that's generally what you'll be doing with your alliance, and that's what generally doing in terms of what you programmed.
Okay. Okay. And one last question is that, like, for TensorFlow, like, how would you exactly use it in, like, I know I asked this, but like in more detail, how would you use it? Are you like given a camera in the kit, or like do you just use the phone, or like exactly what do you use to use TensorFlow, and like how would you use it on the map?
Okay, do you have a control hub or do you have a phone on your robot?
We have a control hub on our robot.
Okay, so for your control hub, you would have to find a USB camera
Yeah.
that you can plug into your control hub. And
so
that
they're
will,
FTC sorry.
that will give you a vision of the field. Now, for how you use TensorFlow, you can look at the external samples, and there will be examples of how you do object detection with TensorFlow. And so I would say follow those examples to find out how to do stuff.
Okay, thanks.
Anyone else? Any other questions? I guess that's about, or I guess no one else any questions. Yeah, that's about it for the presentation. I'll try to make sure to send whatever this information through Playing and Learning. I'll send this presentation to Playing and Learning. I believe they'll be able to send it to you guys. But yeah, I think that's it. Yeah, all right, I hope you guys have a great day. This is the end, and hope you have fun competing in this year's challenge.
Thank you.
Thank you.
Thank you.
Thank you.